Yeah, hi everybody. This is the weirdest PromQL you'll ever see, PromQL for reporting, analytics, and business intelligence. Now, this is my first time at PromCon. It's actually my first conference talk. So you'll have to forgive the kind of somewhat baity title I put together when I was pitching this. We've seen some weird PromQL today, right? Some of Jorge and Manoj's, and I was told about this legendary talk from 5 years ago that's gone down in history. So maybe this is the second weirdest PromQL you'll ever see, who knows? And yeah, here it is. If you want to go now, you can go away happy. No, so yeah, my name's Sam Jewell. I'm a senior software engineer at Grafana Labs. I've been there 3 years now. When I'm not working, I'm working hard or maybe not so hard, looking after my 2 boys. Here we're dressed up as daffodils, dressed up in yellow flowers. When I am working, most recently I've worked on cost attribution. This is helping customers to split up their bill, their Grafana Labs bill, by label typically. And for large companies, large customers, this is pretty important. It means they can break down that huge bill and see who is sending what. And it's also important for teams. Teams can then see their own contribution to that enormous company spend and start to kind of take ownership of that. So it's pretty valuable, you know, in dollars. We dog food this at Grafana, and in the last month or 2, we've cut metrics that were worth $25,000 every month, and we're just getting started. We plan to save even more over coming months. And we're using Prometheus and we're using Grafana to do this, which is interesting because it's not an observability use case. We're storing the data in Prometheus, we're visualizing with Grafana. And that's why I'm here talking today, to share like how we're using Prometheus and to kind of say that you too can use Prometheus for non-observability use cases. Such things as, you know, you could track DORA metrics, you could track like site activity or transactions, you could track alerts or incidents, or like us, you could track usage of like metered cloud spend, metered cloud services and save money. And we heard yesterday from Swiss Re, they described themselves, one of their functions as being a data shop, and the other teams were consuming some of their data. So why use Prometheus and why not kind of like SQL, why not some SQL data warehouse? Well, you know, you could avoid adding an additional data pipeline or database if you happen to have your data there in Prometheus. You can avoid exporting that data, which means you can avoid things like a delay or stale data in some cases. And we can lean on the ecosystem as well. You know, it makes it very easy to build dashboards or alert on that data. So, you know, there's opportunities here. So my goals for the talk are to equip you to do a bit more with Prometheus and hopefully learn something new about PromQL and have some fun doing it if we can. So specifically, I've been looking a lot at usage data. That's things like the count of Prometheus time series, or bytes of telemetry data ingested, bytes of logs, traces data. At Grafana, we also track our consumption of cloud compute resources, so how much CPU and memory we're computing across all our Kubernetes machines to track costs and to manage those costs. So when we look at that usage data, we've got super high, you know, Prometheus is powerful. There's a reason we love it. It's like super high frequency in the time dimension, so we can like see spikes and zoom in on those, see exactly when they occurred and correlate and figure out, you know, what caused the spike and address it, you know, and it, you know, the Prometheus label model also allows us high cardinality, you know, as high as we want or higher sometimes. So we can break down that usage in kind of a space dimension as well and track it down to an instance or a team, you know. And we can address our usage spikes, great, in kind of real time or close to it. But my goal is something pretty different to that. It's to grok those costs and view the data over a much longer time period, so like aggregate over time. So some examples of like times when you might want to do that. At the end of the month, you get sent your bill by your like cloud provider for your cloud compute, and you might want to compare that to your own data and kind of audit the bill they've sent to you, and then challenge the bill if it's wrong, or break down the bill even further than the provider allows you to do with their own data. We might want to just like grok these costs by day, see like daily or weekly how these things are trending and where the sources are coming from, the changes coming from. This one I think is quite an interesting view. This is kind of like a monthly view, and it's cumulative as well. And it allows you to kind of compare across months, where the peaks are. So was this month more than last month? Which of the kind of teams, which of the instances are responsible? And also see some gradients, see some rates, where is it picking up and where is it slowing down? So that's quite a rich view on the data. And then over even longer time horizons, this is like if you buy some credits up front at the beginning of the year and you're burning through them as the year goes on, you want to know, A, that you're not going to fail to spend them all and lose them once that 12 months runs out, and equally that you're not going to burn through it all in 6 months and have to like buy another contract within 6 months. So yes, you want this view of data as well. So yeah. All right, so let's start writing some PromQL. Let's start trying to build some of these visualizations. So we'll start with this daily one. Now, the easiest way is to start from a counter metric. So here I've got traces, size, total. So that's like in bytes. And you can see if I take the sum of the rate, we can see that in August we're seeing around 85,000 bytes coming in every second. And so the reason we've started with a counter is because this is the easiest. So you can just use increase and pass it the time period of 1 day, and it'll tell you how much that bytes counter increased over the day. So on the 17th of August, you can see 7.4 billion bytes were sent or ingested over that last day. But this is kind of continuous data, and it's actually more data than we want to see if we just want to grok this quickly. So we'll change the min step and we'll change to bars, and there we are, we've got a daily view. That's super nice. We can really quickly and easily understand that and share it around the business, And if you want to do that in Prometheus, you can change the resolution input. That takes seconds, so just convert your day into seconds there. But there's something not quite right here. On the 16th of August, if you hover, you can see that bar is the exact time for that data point is midnight in the morning. And what it's done is it's calculated the increase in that count over the past 24 hours. So all of those traces were actually being recorded in the previous 24 hours, meaning the 15th of the month, not the 16th. So we'd like to fix the X labels. So we're just going to add one more thing at this point, which is to offset by 1 day. And you can see the bars move over, and they're now labeled correctly. They're labeled as for when that usage happened. All right, let's move on to something a bit more tricky. At Grafana Labs, we often find that we're working with these gauge metrics and not counter metrics. Well, specifically rates, right? Rate metrics, because we use recording rules to kind of like aggregate and relabel lots of this data. It's kind of like there are too many labels and it's too high cardinality. So we end up with metrics that are more like this, bytes received per second. And so in this case, we want to get to the same daily data, but because it's a rate, we're going to have to integrate the area under the curve. Now, interestingly, there's an open pull request. This guy, Juanjo, also works at Grafana Labs. He's proposed this in kind of July and August. So I'm interested to see where this goes. I really want to see this come in. But in the meantime, there's kind of some tricks to getting this to work properly. So if we look at the docs, we can track down sum over time, which says, it takes a range vector, and what it returns is the sum of all values in the specified interval. Let's just have a look at how that pans out in practice. So if we take this example from 1600 to 1601, we pass 1 minute into sum over time, and it's going to do what we just said, like sum all the values in the specified interval. So in this case, the values are 5, 5, 10, and 10. We get 30. OK, that's what it's giving us for the bytes received. But the trouble is, the bytes received per second is exactly that. It's per second. So what it's telling us is 5 bytes were received in that 1 second, 5 bytes in that second, 10 in that second, and 10 in that second. So we've summed up the bytes received over 4 seconds and not over a minute. So we'll fix that by multiplying by the time period. We'll multiply by 15. This is not kind of in the docs. I've opened a pull request, so we'll see what happens there. But in order to get a true integration and taking account of all that time, we'll have to multiply by the time period or scrape interval. Now, this isn't completely robust yet. If a scrape is missed or a recording rule fails, you might lose a data point. You might lose 2 if the scrape interval actually changes or your frequency of data changes. We can fix that by adding a subquery so that, as long as you execute a subquery, you can guarantee that it's going to evaluate at specific intervals in time, and then we'll cover the whole time range again. Great, and so we can run that, we can see the curve again, and we can present it as days. Awesome, we got there. So we'll do another one. Let's have a look at this monthly view of the data now. So you'd hope that you could just kind of pull out where you had inserted 1 day and stick in 1 month. That doesn't work. We get a parsing error, bad number or duration. And presumably this is because months are different lengths, right? So it's like, what would 1 month be translated into? So PromQL doesn't accept month time durations. In some cases, perhaps you could get away with 30 days, but it's nice to have data for calendar months because, if you look at it 2 weeks later, a month later, even 6 months later, it won't have changed, right? It won't have moved around. So how are we going to do that? Well, there are some functions, some of these you've seen already today, actually. Month, day of month, days in month, and there's others like day in week, for example. There's loads in the docs. So I was just going to show what these actually do. So month will give you the value of the month index. So here you can see it takes 7 during July, 8 during August. There's also, and so you can then apply a condition if you wanted to. You could say the month has to equal 8, and you'll see no data for July and for September. So this might have some potential for us. There's also, I thought I'd quickly show day of month. That climbs from a value of 1 on the 1st to 31 on the 31st. Again, you could apply a condition and use that to maybe lift data just at the start of the month or just at the end of the month, for example. But yeah, so I'm interested to try and isolate August data to begin with. And I've got this kind of synthetic metric here. And what I'd really like to do is kind of take the intersection of this synthetic metric with my actual usage metric and use this synthetic metric as a filter, basically. So intersection would be the AND set operator, but AND doesn't allow for like the selective matching of labels. So it doesn't allow you to use like on or ignore keywords or this group right or left. People have talked about joins earlier today as well. So what we're going to try and do instead is to try multiplying these together. If we're going to multiply them, we want to scale this. We want it to just have a value of 1, really. We don't want it to have a value of 8. And we don't want to like divide by 8 and hard code some value there because it'll be wrong for the other months, of course. So the way we're going to try and do this is we'll introduce absent. Absent always has the value 1, so it's nice in that regard. And when we put month equals 8 into absent, you can see, OK, that metric we had before was absent. And that's why we get the value 1 in July and in September. And then we can reverse the condition. If we do that, we'll say, OK, what about when the month was not equal to 8? Where is it absent? It's absent in August. Fantastic. OK, so now let's try and multiply this by our usage metric. First of all, that's the usage metric. Fine. And if we try to just multiply, we get no data. And if we check the docs, we see binary operator between 2 instant vectors. The operator is applied to each entry in the left-hand side, and its matching element in the right-hand side. And what is a matching element? Well, for one-to-one vector matches, it's 2 entries match if they have the exact same set of labels. So we must not have the exact same set of labels, presumably. So let's have a look. We've got our real metric on the left has like cluster ID, org ID, and on the right we have no labels. That's why it's not working. So to begin with, let's simplify a bit what we've got on the left. I'll just do a sum by ID in order to reduce the number of labels I'm working with to begin with. So that takes me down to 1, but I don't want to throw them all away. I want to keep this one because, as I said earlier, we want that data in the cardinality direction, in the space direction. We want to know which teams, which pods, which instances. Then once we've done that, we'll multiply, and this time we'll use ignoring. And there it is. We've managed to filter a usage metric to a specific month. It's working. There's one more thing I want to do before we move on, and that's here the label is not preserved. You can see the legend just shows the query string. But by adding group left to the join logic, we can preserve the ID and get that to come out in the result as well. OK, so this is still a rate. This is still like bytes per second. We need to integrate underneath the curve again to get this like cumulative usage and just calculate the bytes received. So we'll try and do what we did before. We'll sum over time. This time we'll use 31 days as the period. And I'm multiplying by 60 here, so this time 60 is the scrape interval, or the period between data points. This one is not working, does not work yet. It wants a range vector. So in order to give it a range vector, we'll do the same thing we did before, actually. We'll turn this into a subquery. And we'll make sure that the subquery evaluation interval, that 1 minute, is going to match the 60 so that we get the right numbers. And there we go. We've got like an accumulating usage during the month of August, and we can see like what the total was at the end of August, but also like how it was changing during the month. And this would work mid-month, right? This is nice because you load this up on the 16th of August, you can see where you are. But what's going on in September? Well, let's zoom out and have a look. If you look at September, you'll see the same usage pattern kind of in reverse. It's been flipped upside down. And so we were accumulating usage during August, and we're decumulating that same usage in September. And why is that happening? It's because when we sum over time, the time window we're using is 31 days long. So even on the 30th of September, we look back 31 days, we see that last day in August is still being counted to that usage calculation. We're not interested in that September usage pattern at all. That when we get to the end of August, we basically pay the bill and we start from 0 again. So let's try and throw that away. This is where it gets a bit more fun or hacky, or But let's push forwards. So we'll just apply the exact same filter again, and we'll cut the data off at the end of August. And there we have it. We've got like an accumulating usage for August. And now we can start adding some more months. So let's try and add July. To add July, what we'll do is we'll use the OR operator. This is the union. So we're going to we've got one query at the top and one query at the bottom. You can see the bottom one, I've swapped out the number 8 for 7, so I want month 7. Now, when we union those two together, the labels are going to be identical, and so it's kind of like going to stick them together in time. So there we are. We've got July. Now, I did promise weird PromQL. I've got a kind of like a code golf version for like all months. So once you want 12 months, you could do something like this. You could do like modulo divide by 3 and compare it to 0, 1, or 2. I'm not very proud of this, although it is what's running in the code back home. I'm going to change this when I get back to my desk. Why 3? The reason you need 3 rather than 2 is because February is too short and the other short months. I'm slightly more happy with this one. I think this is slightly more predictable and possible to reason about. So copy it 12 times over. I came from a background in Ruby, and there's a great conference speaker called Sandy Metz. She wrote a book called 99 Bottles of OOP that I absolutely love. And she talks about getting to shameless green. Shameless green is the version that passes the tests with it, and it's shameless. So this is the shameless green version, you know. Anyway, it works. There you can see June has appeared and September has appeared, and that's fantastic. And so just to like put the icing on the cake, this is scoped to a single ID. Here, ID bar. If we like unscope from a single ID and choose an org ID instead, now we can see that rich view of the data we saw before. So yeah, this is like super interesting and potentially like really valuable. How am I doing for time? Oh, I can see. I've got like a little demo, I think. So you can see that this isn't just a picture, but actually works. If you give me 1 second. Ugh. Can't control the... The mouse is like so small. All right. I was just going to like zoom out a bit and interact a little bit, and you could see that it actually works, you know. And we can like show and hide and focus on a single team and like share that URL with our colleagues and tell them to spend less money, you know, or just work harder. So I showed this at the start as well. Unfortunately, I haven't really got time now to cover this one, so I thought I would say, you know, this could be your homework task if you want to go away and have a go, or you can like reach out to me afterwards if you want to. Anyway, so that's it. I hope I've kind of equipped you to do a little bit more with Prometheus and maybe taught you something new about PromQL, and that we've like had a bit of fun doing it. That's it. Thank you, everybody, for listening, and thanks to people who have helped me out to get here.
That wasn't too weird after all, or was it? Okay, questions?
Hi, thank you for the talk. Just a quick question. Have you considered how are you going to deal with the leap year?
Not yet, no.
Now you made it weird.
I think I mean, I guess I have some kind of answer. The beauty of using that month operator is that it knows when the month begins and when the month ends. So that's why I'm using it, right? That's why I'm using it instead of using 30 days. So yeah, I'd hope that this would like help me get there, and I wouldn't have to think about it.
Can you explain again why you have to use the ignoring instead of an on parentheses for the join part to work?
Yeah, let me see if I can get back there. It might be that I could have used on and then empty brackets.
Yeah, that's the form I'm used to seeing. So I'm wondering if if there's a specific reason why it had to be different.
No, so typically like you've got a set of labels. You might have like 3 labels. And if you want to join on one of them, then you can either say on that one or you can say ignoring the other 2. And yeah, both do exactly equivalent things. Yeah.
Thanks for the talk. Very interesting. I have a comment and question. The comment is that it looks like that this ignoring absent code can be replaced by scalar. Did you consider scalar function?
By what? By a scalar function?
Scalar, yeah, scalar. That's the first question. That's just comment. And the question is, did you consider time zone? Because as I know, month function doesn't returns result on UTC time zone. I recommend you adding time zone support in this query.
That's a really good question, yeah. Through my work on this, I'm like, and someone asked about like a leap year. I'm often hitting time zone issues, and they kind of manifest themselves most when daylight saving occurs, actually. And so I'll get I'll get January, February, March, and then I'll get March again, and then I'll get April, May, June or something. Or I'll get a gap. And so I've like discovered and reported like quite a few bugs, actually, or at least one, probably 2 or 3 in Grafana around time zones and the way they're handled. But basically, we build dashboards for our customers that show their bills in like a billing dashboard in Grafana, and we're also building like Grafana app plugins that show how their bills break down by team. And the bills are calculated in the UTC's time zone. And so as long as we are able to like always work in UTC, then we can like show them their actual bill and label it with the right month. And you know, it's not relevant to them to see their bill in their local time zone because it won't actually match up with what we're billing them. So mostly we just work in UTC for this work.
UTC for the win. Quick announcement, the first 2 Lightning Talk speakers, Kieran and Christian, please come already to the front so we can get started right after this.
Hello, thank you for the talking, this is really amazing. Just a very maybe dumb question, it's like, if it's only dashboarding, doesn't work to have a variable using the days in month function and getting the return from this expression using as like the range selector for the query?
The days in which month, though? Like, surely you're looking at multiple months at once in some versions of the dashboard?
Oh, yeah, I mean, like, for example, creating a variable using days in month function and providing maybe like the uptime series or something like that, just to get in the month it's going to be evaluated, and then using the return from this function as the range selector, you know. Does good work or not really?
Yeah, I think those kinds of solutions can work, yeah. We've done some pretty gnarly things as well with dashboard variables. But yeah, like if you had a dashboard that's like viewing one specific month, for example, then yeah, for sure.
Okay, thank you.
Yeah.
I have one question, if I may, on your left.
Nice.
Hello, amazing talk, and I'm just curious, like you do incredible analytic queries using PromQL, right? And typically, data analytics, they just prefer, maybe SQL and like other languages. So I'm just curious, like what you have been missing in PromQL that you would do easier in SQL. What could we add, or should we even? Yeah.
We had a hackathon project. So before I joined Grafana, I'd never worked in observability. I didn't know what a time series database was or what logs were, basically. I'd been using a tool called Looker that got acquired by Google, which is a BI tool, and I loved it. It was a dashboarding tool. I was like, oh, I love this dashboarding tool. I can go and work on Grafana on dashboarding. Anyway, how little I knew. But what there was in the SQL world, you could have like a materialized, you're writing these subqueries and subqueries and subqueries, but often like if you've got a subquery, you want to give it a name and you want to make it a source of truth for your business.
So recording rule.
Exactly. But there were different versions of this. You could have materialized views, or you could have views that were not materialized. Now, recording rules are like materialized views, but we don't have anything which is like an unmaterialized recording rule, where you could extract a portion of your query, you could give it a name, and then refer to it in other places, and it would become a source of truth across your team or your business. I'd be interested to see a kind of recording rule that's not materialized. I think that might have some potential.
Thank you. Yeah, I think Victoria Metrics QL, they have variable. Maybe that's kind of similar purpose. So yeah, there's some room to innovate. Thank you. Any last questions?
Okay, then thank you again for the weirdest talk ever. And yeah.